Okay, good. So you want to learn how to model optical fibers in COMSOL? Well, you've come to the right place. Let me tell you more about this course. So in the first section of this course, we discuss how to model optical fibers from scratch. So if you're a complete COMSOL beginner, this course is for you. Also, if you're a little bit familiar with COMSOL and you want to learn how to model optical fibers, then also you can enroll into this course. There are not many prerequisites for this course. You just need to have basic knowledge of optical fibers, how they function, and the modes. In case you are not familiar with modes, then let me tell you that mode is the path that light takes while traveling through the fiber. So basically, the field distribution that you see here shows that the light is present only at the bright regions and it is not passing through these blue areas. And so this kind of distribution is called as a mode. So now that you know about mode, you can enroll into this course. So in the first section of this course, we start with introducing COMSOL as a software. We discuss the user interface, how to create parameter list, then how to build geometries, how to assign materials to these geometries, then meshing this geometry, and finally a mode analysis. So all these concepts are discussed detailed in the very first section. And in the second section, we talk about some advanced settings such as building custom materials and boundary conditions such as impedance boundary condition, perfectly matched layer, and scattering boundary condition. And then in the further sections, we have 4 projects. So idea behind these projects is to introduce you with different cases of optical fibers and at the same time provide you with the unique skills related with COMSOL. So in these projects, we will discuss step index fiber, then single mode versus multi-mode fibers, then visualization of vector fields. That is, we see how the electric and magnetic fields are oriented in a given mode. Then we talk about double-cladding fibers, then overlap factor or power confinement. This means how much percentage of power is maybe confined to the core or cladding. Then we also talk about bending of fiber. That is how the mode is affected when we bend a fiber. Then how to perform a parametric sweep over some parameter. And then we talk about microstructured fibers, how to model these complex structures in COMSOL efficiently. And then we also talk about how to plot longitudinal and transverse fields. We discuss all this in 6 sections and there are 15 lectures. And after each lecture, you will find a quiz, which is really helpful. So there are 15 quizzes. Then there will be resources that includes some presentations. So for many lectures, we talk about concepts behind particular model. So those presentations are available. And also in one of the lectures, we talk about various fiber parameters. So for that, we discuss a Python tool. That tool is also available for downloading. This course is not a mathematical course. There will be no derivations, no eigenmode, distribution. We will not get into mathematical details and so. Therefore, this course is about COMSOL. We learn about COMSOL as a software for modeling optical fibers. My goal is to teach you how you can model various complex geometries and calculate quantities which are commonly calculated in the field of research and engineering. And so, I really hope to see you in the course.